We introduce Implicit-PDF, a method to represent expressive probability distributions over the rotation manifold for general pose estimation. Consider assigning an orientation to the objects in the images shown. For these three, it is unambiguous. However, in many cases, symmetries and uncertainty make the problem of assigning a single orientation per scene ill-defined. Consider the objects in the bottom row. The train rounding the bend does not point in a single direction, and there is no front of the box or vase. In these cases, the best estimate for the orientation is multi-valued. For a coffee mug, the orientation is well-defined when the handle is visible and multi-valued when occluded. Our goal is to predict arbitrary distributions over orientation to tackle the pose estimation problem in its most general form. Most work on pose estimation treats the problem as if there is a single correct answer, in part because annotations are almost always in the form of one pose per image. When the ground truth is most accurately described with a distribution, as we illustrate with the simplified 1D example, a single rotation is clearly inadequate. Training is also difficult in these situations, as losses will tend to split the difference and capture none of the descriptive orientations. Prior work has expressed uncertainty by predicting the parameters for a unimodal distribution. Normalizing these distributions is onerous, and they still cannot represent multiple valid orientations. A mixture of parametric distributions can express multiple modes, though with the same difficulties of normalization, and now with an issue of mode collapse. Further, the distributions which can be represented are limited. Another approach is to predict a discrete likelihood grid or histogram. A major downside is that the output lies in a fixed grid, and the size of the network output grows exponentially in the dimensionality of the space. In this work, we consider representing the distribution over rotations with an implicit function. This is a non-parametric representation that lets us predict arbitrary distributions with continuous resolution. The architecture for our Implicit-PDF model is quite simple. We use a multi-layer perceptron whose inputs are a vision description of the image and a single rotation. The output is proportional to the probability of that rotation given the image. This design is similar to recent works using coordinate-based implicit representations of volumetric properties. We positionally encode the rotation with sinusoids, which has been shown to help output high frequencies. To normalize the outputs, we evaluate at a set of rotations on an equivolumetric grid over SO3. We train the model with a likelihood loss given only a single ground truth rotation per image. Equivolumetric grids over SO3 are generated in a recursive fashion. To visualize distributions, we mark the direction of the z canonical axis on the surface of the two-sphere and use color to display the tilt around that axis. To put Implicit-PDF to the test, we introduce a challenging new pose estimation dataset of symmetric solids, now on TensorFlow datasets. There are platonic solids with discrete symmetries and surfaces of revolution with continuous symmetries. The cube and the cone roughly correspond to the case of the box and the vase shown earlier. The full set of equivalent orientations is provided for evaluation. The 60 discrete symmetries of the icosahedron are shown on the left, and the 2 continuous symmetries of the cylinder on the right. These are challenging distributions to express, and even more so to learn when supervision is limited to a single orientation per image. We also include 3 marked shapes shown with shaded backgrounds. These yield rich rotation distributions which differ when the markings are visible or occluded. We now display Implicit-PDF predictions with the ground truth as outlines. The full continuum of rotations is correctly predicted for the cone, as are all 24 symmetries of the cube. When trained on the marked solids, Implicit-PDF predictions express the information available in the image. When the X is not visible on the sphere, half of the possible orientations may be excluded. When the single red face of the marked tetrahedron is visible, the output represents the 3 equivalent orientations of that face. There are 9 modes when only 1 gray face is visible. We compare with Deng et al., which predicts a mixture of unimodal Bingham distributions. The individual Bingham modes fail to adequately cover the continuous symmetry of the cone. By contrast, Implicit-PDF sharply captures all symmetries. By using the mode of the predicted distributions, Implicit-PDF is competitive with state-of-the-art on the challenging Pascal3D dataset of real images exhibiting ambiguities and near symmetries. To summarize, our method implicitly represents arbitrary distributions over the space of rotations. Please visit our website for code and a challenging new benchmark dataset for pose estimation. On this dataset and others, Implicit-PDF successfully handles discrete and continuous symmetries, uncertainty, and still does remarkably well on unambiguous single-value pose estimation. Thank you for watching.